Hey guys, welcome to 1.1 Arithmetic Sequences and Series. Now, a sequence is an ordered list of numbers, and a series is the sum of a sequence. Let's look at some sequences. Now, the formula for the nth term of an arithmetic sequence is un equals u1 plus n minus 1 times d. And here un is the general term of the sequence. u1 is the first term of the sequence. N is the number of the term you're finding. And d is the common difference. In an arithmetic sequence, that's the number being added or subtracted each time. Let's take a look. Here is a sequence of numbers. 5, 8, started at 2, 2, 5, 8, 11, 14, 17. So to write down the common difference, we look to see if we have the same difference between each number. 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3, and 17 minus 14 is 3. And that means that our common difference is 3. Another way that I do this sometimes is I'll just pop right on over to where it's written and I'll look and I'll just say, okay, well, I need 3 to get there. I need 3 to get there, and so on and so forth, and just kind of write in the difference in the gaps. All right, well, once we know that the common difference is 3, to find the 10th term, that means my n is 10. I know that my u1 is 2 because of the sequence written here, and I found that my d is 3. So plugging it into my formula from here, my un is u10, my u1 is 2, my n is 10, and the common difference d is 3. And when you add and multiply that out, you will find that the 10th term in the sequence is 29. To find the 25th term, we do the same thing, except this time n equals 25. So u of 25 equals 2 plus 25 minus 1 times 3. And your answer is 74. Now that's pretty straightforward. There's a couple of ways we can go about this. When we're not looking for a term, we're looking for a missing piece. All right, so here we know the second term is 1 and the 7th term is 26. We want to find the first term and the common difference. So you'll see here that I wrote the second term is 1. So that means that 1 is equal to the first term plus 2, which is n, minus 1 times d, or the common difference. I also wrote that since u of 7, or the 7th term is 26, 26 equals the first term plus 7 minus 1 times the common difference. And then what I did was I set both of those equations equal to the first term. And so here I went ahead and I subtracted 2 minus 1 is 1 times d is just d. And then I subtracted it to get u1 by itself. So that means that u1 equals 1 minus d. Again, over here, 7 minus 1 is 6. 6d subtracted from both sides gives me 26 minus d equal to the first term. Now, substitution tells me that if two things are equal to the same thing, then I can just make them equal to each other. So if u1 equals 1 minus d, I can then substitute that in for u1 here, which is what I did. 1 minus d equals 26 minus 6d. I then subtracted 1 from both sides and got negative d equals 25 minus 6d. I then added 6d to both sides and got 5d equals 25. Dividing by 5 gave me the common difference, which was 5. From there, I could plug into either one of these equations to find what I'm looking for. I chose to plug it into the first one. The first term is equal to 1 minus 5, because I plugged in 5 for the common difference, and I found that the first term is negative 4. From there, to find the 100th term, well, n is 100, the first term's negative 4, and the difference is 5. So I write out my equation. The 100th term is equal to negative 4 plus 100 minus 1 times 5, and that equaled 491. All right, let's move on. Okay, so here we have a sequence of numbers, 6, 10, and 14. A little typo there, sorry about that. And then some numbers, and then 50. So what's the common difference? Well, 10 to 6, that's 4. 14 to 10 is 4. So my common difference is 4. So how many terms then are in this sequence? Well, I know that my general term, a of n, I need it to equal 50. I also know that my first term is 6 and my common difference is 4. So if I plug that in, 50 equals 6 plus n minus 1 times 4. I'll subtract 6 from both sides to get 44 equals n minus 1 times 4. And then I'll divide by 4 to get 11 equals n minus 1. From there, I just add 1 to both sides to find that n equals 12. There are 12 numbers in this sequence. All right, so the sum of n terms in an arithmetic sequence is the sum of n equals n divided by 2 times the sum of the first and last terms. All right, so we wanted to find the first 4 terms of an arithmetic, we have the first 4 terms of an arithmetic sequence here, 5, 8, 11, and 14. And you see I just wrote in the common difference and the first term immediately. Next, it wants me to calculate the sum of the first 80 terms. But to do that, I need to know what the 80th term is. Well, that means that my n is 80. So u of 80 equals the first term, 5, plus n, 80, minus 1 times the common difference, 3. Multiplying and adding out, I get 242. So then, the sum of the first 80 terms equals 80 divided by 2 times the sum of the first term and the 80th term, which gives me a total of 9,880. Next, let's find the sum of this series. -3 plus 1 plus 5 plus 9 plus a whole bunch of other stuff plus 81. That's what makes this a series. It's a sequence written with the addition symbol in there. So I know that I'm summing it. All right, I wrote in that 4 is the difference between each pair of numbers. So my first term is -3, my last term is 81, and my common difference is 4. Now, this time in order to solve, I'm going to have to solve for n. I need to know how many numbers are in this series in order to find the sum. So I know that my general term needs to equal 81. So 81 is equal to the first term, -3, plus n minus 1 times the common difference, which is 4. I'm going to add 3 to both sides to remove it from the right-hand side. So 84 equals n minus 1 times 4. To get n minus 1 by itself, I'm going to divide both sides by 4. So 21 equals n minus 1. To get n, I simply add 1 to both sides and find that there are 22 terms in this series. Therefore, 22 divided by 2 is multiplied by the sum of -3, the first term, and 81, the 22nd term, which gives me a total of 858. Okay, let's take a look at a real-world example. The sales of smartphones are growing every year. At the end of 2006, the number sold was 25 million. And at the end of 2010, the number sold was 35,800,000. Assuming that the sales figures follow an arithmetic sequence, first calculate the number of smartphones sold at the end of 2008. Now, it would be really easy here to fall into the trap of finding the wrong term. Because if you just do 2008 minus 2006, you'll say, oh, 2. So the second term then is going to be 2008. No, take a look here. If 2006 is the first term, 2007 is the second term. So 2008 would be the third term. So my first term I know is 25 million. And my third term is going to be 2008. Looking at 2010, that is my fifth term, and I know that that's 35.8 million. So I'm going to use these two terms to solve for the common difference. I know that when n is 5, un is 35.8 plus my first term is 25 plus, this was the fifth term, so it's 5 minus 1 times the common difference. Subtracting 25 from both sides gives me 10.8 equals 4 times the common difference. Dividing by 4 then tells me that the common difference is 2.7 million. Then we're going to come back and plug that in to find the third term. The third term, where n equals 3, is equal to the first term of the sequence, 25, plus n, 3, minus 1 times the common difference of 2.7. And you get 30.4 million, or 30,400,000. Next, let's look at 2015. Well, counting down, that is my 10th term, so n equals 10. And u of 10 is my first term, 25, plus n, 10, minus 1 times the common difference of 2.7. And you find that at the end of 2015, we should have sold 49.3 million, or 49,300,000 smartphones. All right, let's take a look at your practice. Consider the arithmetic sequence that starts 5, 16, 27, 38. What is the common difference? All right, it takes 11 to get me from 5 to 16, 11 to get me from 16 to 27, and 11 to get me from 27 to 38. So my common difference for this sequence is 11. So what would be the next three terms? We'll just add 11. So 38 plus 11 would be 49. 49 plus 11 would be 60. And finally, 60 plus 11 would be 71. All right. So what then would be the 20th, 50th, and 100th term of this sequence? Okay, I need to find U20, and I know that U20 is going to be my first term, which is 5, plus n, which in this case is 20, minus 1 times my common difference, which is 11. All right, I'm going to do that on my calculator here. 5 plus 20 minus 1 times 11 is 214. That is the 20th term of my sequence. All right, I'm going to attempt to make a semicolon here so that I'm kind of letting myself know that these aren't sequential. To find the 50th term, that is U50. Now my n is 50, so it's going to be 5 plus 50 minus 1 times 11. On my calculator, 544. All right. And last but certainly not least, I'm going to find U100. Okay, which is going to be 5 plus 100 minus 1 times 11. And I don't know if I mentioned this to y'all, but you do not have to print this out in any way, shape, or form. You can absolutely just write your answers on a separate sheet of paper. All right, 5 plus 100 minus 1 times 11 is going to be 1,094. And there you have the 20th, 50th, and 100th term of this sequence. Let's move on. All right. The following sequences are defined by their general terms. So work out the values of the terms requested. So here you see they put the common difference at the beginning rather than the end. That's totally fine because we know that multiplication is commutative. So we can change the order of the elements in multiplication and still have the correct answer. So here, to find each of these, I'm simply going to plug in n to the general term. So 3 plus 6 times, my n is 3, minus 1. I find that the third term of this sequence is 15. What about the eighth term? That's 3 plus 6 times 8 minus 1. The eighth term is 45. All right, and then to find the 20th term, we're going to do 3 plus 6 times 20 minus 1. And so 117 is the 20th term in the sequence. Moving on, I want the second term. 23 plus 2 times 2 minus 1 is 25. So the second term of this sequence is 25. All right. The 10th term, 23 plus 2 times 10 minus 1 is 41. And to get the 63rd term, we'll do 23 plus 2 times 63 minus 1, which is 147. All right. I want the first term. I don't have to do anything. The first term is right here, 10. However, if you did plug in a 1 here, that would be 0. 3 times 0 is 0. You end up with 10 anyway. Let's find the 8th term. 10 minus 3 times 8 minus 1 is negative 11. Next, we have the 13th. 10 minus 3 times 13 minus 1 is negative 26. Here, we have negative 105 plus 11 times n minus 1. The fifth term, negative 105 plus 11 times 5 minus 1 is negative 61. The 10th term, negative 105 plus 11 times 10 minus 1 is negative 6. And finally, for the 15th term, that's negative 105 plus 11 times 15 minus 1, 49. All right, and that is the last one of those. Let's go to the last row in this table. Here we have 5 plus 1/2 times n minus 1. All right, let's find the second term by plugging in 2 for n. 5 plus 1/2 times 2 minus 1. And we get 5.5 or 5.5. I'm going to go with decimals. You can go with decimals or fractions, your choice. Let's find the seventh term. 5 plus 1/2 times 7 minus 1. And we find the seventh term is 8. Finally, the 100th term. 5 plus 1/2 times 100 minus 1. 54.5 or 54 and 1/2 is the 100th term in this sequence. All right, that was using the general term to find different values based on the term requested. Next, we're going to be working out the general term based on the first 3 terms in the sequence. All right, so here my n is 3 to get here, but I don't really need that. What I really need here is my common difference. So to get from 7 to 15, that is 8. To get from 15 to 23 is 8. So my UN is going to equal my first term, which is 7, plus n minus 1 times my common difference, which is 8. All right. Negative 6 to negative 2 is 4. Negative 2 to positive 2 is 4. So my general term is first term negative 6 plus n minus 1 times 4. All right. 3 to 3 1/4 is 1/4. 3 1/4 to 3 1/2 is a difference of 1/4. So a common difference of 1/4, that means that my general term is going to equal my first term, 3, plus n minus 1 times 1/4. Last one. 8 to 5.25. I believe that's 2.75. I'm going to check on my calculator. 8 minus 5.25. Yep, 2.75. Let's double check. 5.25 minus 2.5. 2.75. So my general term is going to equal my first term, which is 8, plus n minus 1 times. Now, you note how these are getting smaller? That means that my common difference is negative. So it is negative 2.75. And there we go. Okay. Let's find the sum of these arithmetic sequences. 3, 9, 15 to 10 terms. All right. Well, I need to find the common difference. 6 and 6, good, so that I can find U10. That's going to equal my first term plus 10 minus 1 times my common difference, which is 6. All right. 3 plus 10 minus 1 times 6 is 57. So then, the sum of the first 10 equals n, which is 10, divided by 2 times the sum of the first term and the 10th term. Okay. 10 divided by 2 times 3 plus 57 is 300. Next, we're going to do this sequence to 30 terms, 2 and 2, so my common difference is 2. U30 equals first term 6 plus 30 minus 1 times 2. All right, 6 plus 30 minus 1 times 2 is 64. And that means S of 30 equals N, which is 30, divided by 2 is multiplied by the first term plus the 30th term. Okay, so 30 divided by 2 times 6 plus 64 gives me 1,050. Next, we are given our general term here to 100 terms. Okay, so I know that I need to find the 100th term. So that is U100, which equals the first term, which is 3, plus common difference 6 times n is 100 minus 1. Three plus 6 times 100 minus 1 is 597. So the sum of the first 100 terms is equal to n 100 divided by 2 times the sum of the first term, which is 3, and the 100th term, 597. One hundred divided by 2 times 3 plus 597. I got 30,000. Okay, last one of these. I have my general term here, and I want to find 25 terms. So that means I need to find what the 25th term actually is. So that's going to be -5 plus, looks like my common difference is 7 times n, which is 25, minus 1. All right, -5 plus 7 times 25 minus 1 is 163. So the sum of the first 25 terms is equal to 25 divided by 2 times the sum of the first term, -5, plus the 25th term, 163. All right. 25 divided by 2 times -5 plus 163 is 1,975. Okay, a couple more to go. All right, an arithmetic sequence has first term 20 and seventh term 44. What is the common difference? The general term and the sum of the first 7 terms. All right. When n is 7, un is 44. And that equals 20, which is the first term, plus n, which we know is 7, minus 1 times the common difference. If I subtract 20 from both sides, I get 24 equals 7 minus 1 is 6, d. Divide both sides by 6, and we find that 4 is our common difference. So that is the first part of our answer. That means that the general term u of n is equal to, our first term is 20 plus n minus 1 times, that 4 got away from me there, 4. And that is the second part, the general term. Okay, last but not least, the sum of the first 7 terms is going to be n, which is 7, divided by 2 times the sum of the first term and the 7th term. So let's put that in our calculator. 7 divided 2 times 20 plus 44. 224 is the sum of the first 7 terms in this sequence. All right. An arithmetic sequence has third term 2 and 8th term 47. All right, if you remember this from the notes, we need to do 2 different equations. So when n is 3, I know that 2 equals the first term plus n, which is 3, minus 1 times the common difference. And I'm going to rewrite this. I know that 3 minus 1 is 2. So I'm going to subtract 2d from both sides. So 2 minus 2d is equal to u1. Just kind of make a little split here, because I also know that u7 is 48, or sorry, 47. So 47 equals u1 plus, in this case, n is 8 minus 1 times the common difference. All right, I know that 8 minus 1 is 7, so I'm going to subtract 7d from both sides. So 47 minus 7d D equals the first term. Cool. So now that I have 2 minus 2D equal to the first term, I can substitute that into the first term statement here. So I can write, actually, I'm going to substitute this one here. I'm going to write that 2 minus 2D is equal to 47 minus 7D. I'm going to subtract 2 from both sides to get started. That leaves me with negative 2D over here. And then here I have 45 minus 7D. I'm now going to add 7D to both sides, which gives me 5D equals 45. Finally, I'm going to divide both sides by 5. So I have found that the common difference is equal to 9. All right. Well, I also know that U3 is 2, and I was able to rearrange that to get this right here. 2 minus 2D equals the first term. So I'm going to get the first term real quick here by simply putting in my calculator 2 minus 2 times 9, which is negative 16. If you want to really double check that, you can pop it into the second one as well. 47 minus 7 times 9, and you get negative 16. All right, so that is the first term of my sequence. The general term then is UN equals negative 16 plus N minus 1, make that 1 a little better, there we go, times 9. Last but not least, we need to find the sum of the first 20 terms. So the sum of 20, where N is 20, equals 20 divided by 2 times the sum of the first term and the 20th term. Now, I don't know the 20th term. However, I can find it quite easily by plugging in 20 for N in the general term. So negative 16 plus 20 minus 1 times 9, 155. So then, 20 divided by 2 times negative 16 plus 155 is 1,390. Okay, the sum of an arithmetic sequence to the first 10 terms is 240. The first term is 6. What's the general term of the sequence? Okay, so for this, we're going to find the 10th term and use that. So I know that S10 is 240. And I know that I got that by doing 10 divided by 2 times the first term plus the 10th term. All right, I am going to divide both sides by 10 over 2 or by 5. So now I have 48 is equal to 6 plus U10. Subtracting 6 from both sides lets me know that the 10th term of the sequence is 42. Okay, we're now going to use that to find the common difference. I know that the 10th term is 42. So 42 must equal the first term, 6, plus n, which is 10, minus 1 times some difference. Well, I'll subtract 6 from both sides. So 42 minus 6 is 36. Equals 10 minus 1 is 9. D. Divide both sides by 9, and I find that my common difference is 4. So now I can write the general term of the sequence. UN equals the first term, 6, plus n minus 1 times my common difference, which is 4. Good job, guys. All right, here is an investigation for you to do on your own. And if you can find one, awesome. Go to Schoology in the unit for sequences and series. There's going to be a discussion, and you can post the sequence that you came up with. Great job, guys. I'll see you next time for section 1.2, which will cover geometric sequences and series. Have a good one.